record, then we start. I was wondering why people are failing to join. I forgot to send the link. I sent the banner for invitation.
Hello, sir.
Hello, Daniel, how are you?
All good. How are you?
Fine, fine. It's already 22 past. It was my mistake with the link. Sorry for that. I think maybe others also are affected. But I'm recording this for the developer experience so that when we need the video, we can always go over it again. All right, I think let's start. Those maybe might have been waiting to join due to the mistake with the link, but the two of you will benefit. And then this, you will understand it more what today's session is all about. Let's start. Going to share my screen. Let me share this short presentation that I have here. You can download it, bookmark it. You will use this with your students. Actually, if I can show you here, what we are doing, he has got this, which I have for you. It has got this. Let me run it properly so that you see. The session for today will introduce you to this very important technology in Cardano. This technology is called Layer 2 Solutions. It is this one here. If you go to the project proposal, we are going to see that one of the technologies that we need to introduce new developers and students is Cardano Layer 2 Solutions. Okay, now let us, how do you find it? When you get here, you just type Hydra. There it is, I've added this link. That's the link that I have given you. So when you get lost, come here, type Hydra. So anyone who will watch this video, if they want to see this, they can come here and type Hydra. Right, this is a rough summary of the installation that I have put together. Right, I cannot guarantee you that this installation will work, but it will introduce you to the concepts about the Hydra installation prerequisites, whatever, on a high level. The actual original correct documentation link you should follow is this one. I will also send you. The moment you have got the link to the other one, immediately you have got the link to this one. This one is supposed to be a short summary to introduce you. Actually, let me push this link to the top. I would prefer people to use the original link, the documentation, than this one here. Because this one is just a summary, because you know our time is 1 hour. So we normally try to have a short summary for anyone to follow. Okay, so I will show you again. Right. When you come here now, I think you can quickly click the original Hydra documentation here. It is very straightforward. This one, it takes you through the installation here. But first, I want us to discuss about what is a layer 2 Cardano solution. I'll try to discuss it in a very simple way. Forget about these technical, difficult things. Why? Because the two of you, if you understand it, you have got more than 20 students under you. Actually 30. You, Xavier, you've got about close to 20. And you, Daniela, actually, you, Daniela, you've got almost more than 50, including the what do you call it? The DRC French community, the Ivory Coast French community, all those ones there. They all need to be introduced to Cardano Layer 2 solutions as developers. Right. I will explain it in simple ways. We have got the Cardano blockchain with a ledger which is running, which everyone uses. We all know about that. There is a problem of scalability. It is not as fast as we all would want it to be. Now, Cardano designed a possible solution to the scalability. It is called the layer 2. Layer 1 is the actual Cardano, which we are used to. Right. The layer 2 is a technology that is meant to make layer 1 fast. There is another documentation here from Sebastian Nagel that gives a high level of this Cardano solution for ultimate layer 2 scalability. To make it simple for you, last year they tested this Hydra layer 2 to check how fast Cardano transactions can be. It was a test, and they invited everyone to join. It was a game, the Hydra Doom game. Invited the whole world, people all around the world to join and play the game. Meanwhile, they were recording the transactions per seconds that this solution could reach. It hit close to 1 million transactions per second. It broke the record. This technology from Cardano, this one Hydra, let's call it layer 2 because it's not the only one. There are others too, but this one was tested last year, this Hydra technology. It reached 1 million transactions per second, and it shocked the whole world that Cardano can produce such a very fast technology. If you want to understand it, because I know you are a student, you are starting with this, want to understand this, I want you to think of Visa, you know Visa, that credit card technology. How many people are using Visa? Millions and millions. Good. Means it's scalable. But then we ask, how many people can use Visa concurrently at the same time? How many transactions can that technology run when people all over the world are transacting in Visa at the same time? That transaction speed is what we refer to. This thing is very fast, efficient, and it is very scalable. It can accommodate a large number. So you can search on internet. When I searched last time on internet, I think the Visa transaction speed let me not say what I read last time. Yeah, I'm still correct. Still correct. 65,000 transaction messages per second. Okay. Then what about this Hydra Doom last year when we tested it? What did it hit? It hit 1 million. You can check now. Over 10 times faster than Visa. That is why I'm saying this is a marvelous, incredible technology from Cardano developers. Okay, how does it work? This is what we are discussing now. How does it work? Right, we have got a main Cardano blockchain. It allows participants on Cardano blockchain to run their own what we call separate mini or layer 2 blockchain, call it Hydra head protocol. Offline. When I say offline, off the layer 1. So when I say Hydra head protocol, this is one. I'll explain this one so that you see. Here I've got 3 users or 4 users. Let's call them, they are playing a game. They tested with a game called Hydra 2. A, B, C, D. These are game players. They are playing their game. Their game is connected to Cardano node, but there is an X and a Y Hydra. No, these are nodes. You can see the Hydra node is this one, where there's this round blue, where the user in. That's a Hydra node. The blue for each user, it is the Hydra head party, the player. Then you see this square, this rectangle, Hydra client. So you have got 6 clients. You've got XY, you've got D, C, B, A. So how it works is, go to Cardano, the normal way we do our transactions on Cardano. But then this allows us, once we start the transactions, we go offline with our states. For example, we are paying each other. We are going to be paying each other on an off-chain layer 2. But that layer 2 has got all the features of layer 1. It has got all the security, consensus mechanism of layer 1. So it means now this layer 2 is going to be pretty fast. Why? Because it's just local. Our transactions are just local. Rather than on layer 1 where everyone in the whole world is also posting the same transaction. You have to wait for the miners to run through the mempool, validating those transactions. Then you end up taking about maybe 5, 6, 7 seconds. But with this one layer 2, because now we are on our own, paying each other within layer 2 state, there is no queuing. So everything is just very fast. You just send something, then they receive it immediately. And it is best for certain applications that need speed, like gaming. So this is, in short, what I can explain to you as a layer 2 solution to Cardano scaling solution. Did you understand it? Let us have some questions on this thing here. Let's have some discussions here. Do you get it, Xavier? Daniel?
Yes, sir. It's very understandable, sir.
You are understanding.
Especially this.
And
Yes, sir. Yes, sir. I get it, sir.
Daniel?
Yes, sir, it makes sense.
It makes sense.
Yes, sir.
Yes. Remember the layer one, everyone is on the layer one. So they have got millions of people who are doing what we are doing transactions, but those transactions are queued on a place called mempool. So the miners, those take pool operators we have in Cardano, they are busy collecting those transactions on mempool every milliseconds and they're validating them. That is why after some time you see your transaction has been validated. But that is not scalable. It is far less than 65,000 transactions per second on Cardano. On Bitcoin, it's even worse. It's around 7 transactions per minute or so. Bitcoin is even worse slow. But this Hydra layer 2 solution, I also took part in this testing of it. It hit 1 million transactions per second. In 1 second, 1 million people would send and receive transaction in a second. It was possible because when you join the game, then it pulls out certain groups of people. Let's call it states. So that, for example, let me give you an example. We can be playing, we here in South Africa, we only play local. Nigeria, you play local. Then the winners, they go and play locally. But now there is no need for these two, what we call it, clock, what we could chalk the main network, is what happened in Ethereum in 2017, 2018. When Ethereum introduced NFTs around 2017, 2018, along that side, they introduced gaming on blockchain. And it slowed down and brought the whole Ethereum down. And then it showed everyone that this scalability is a big issue. And even till today, Ethereum is fighting to solve that scalability problem. But when Cardano designed their blockchain, they immediately had a roadmap for scalability. Put in security on layer 1, and then they put in this layer 2. Now, before I go to how we install it, because I want you on your own to try and install it and play around with it before we go into looking at coding it. How I can suggest we code it. I would suggest we code it as a marathon on our side, a mock layer 2, so that you understand the features and the concepts. How, okay, you have a mock. Normal way we do it. We produce maybe a Hydra protocol, a mock app. So normal way we do it. All right. Before we go there to do that, what I'll require us to do is let's have some questions if we have got some questions. Right. If there are no questions, then I'm going to walk you through this documentation here. Right. It is very simple. What I like with this documentation, it is from step 0 to step 6. It flows. But I went through these steps. It didn't complete the installation of the node. So the node somehow it failed. But then where it fails, you can try it on your own there. And then as long as you know the steps for installing it. The other thing, I'm going also to introduce you to some CLI commands maybe you are not used to. Right. Here are the prerequisites. This uses a terminal, this test, which is here. It uses a command line. So in this case, I can just open a command line so that you see from here. Right. We can run it as 3 of us with your machine there, my machine, Daniela's machine. That would be the best recommended. Then we send each other the public addresses. Then we create our own layer 2 blockchain, mini small blockchain with a Hydra protocol. Right, and then this other one, that each of our wallets must have test header pre-production. We are already doing this. Some tools that we need, curl, this is a command line tool. So I can say curl, version. Right, I've got version 8.5. This is another tool for extracting zipped compressed files. I think all our machines have got tar and zip. And there is this JQ tool. Well, I'm not familiar with it. You can check what it is for. Then WebSocket. Those are what we need. So we can run this. Now, this one is on Windows and Mac. Sorry, it is on Linux and Mac. So for Windows, you need to install on your Windows WSL2, Windows Subsystem for Linux 2. Then you'll be able to do this like we are using Linux. Right, the first thing is to do this installation. These installations are very simple. You simply copy, you go to your command prompt, you paste, you run, then it will start installing. I've already installed that. Let me open another terminal, close that one. Okay, I've already done that. So by clicking here and installing, it will make a directory bin, and then from there, select the Hydra version. Then the curl command is going to pull up or run this URL and then download this zipped version of Hydra. And then it will download onto this bin. And then here it will unzip, it will uncompress. It is compressed then into this. I did that. I can just check if it is, but let me not check that side. And then here is another curl command here that is downloading stuff. And this one again. It is downloading. This is what the Linux -AMD. And then this command here, it is allowing this directory to execute the files inside. By default, when you download things onto the bin in Linux, those executable are not allowed to run. They don't have permissions. So this is a Linux command for giving permission to all the files that are in this directory, the permissions to be run on the local machine. It's a security thing that you give permissions to the files you have downloaded to run. And then you verify by clicking this. Right there, you can see the help shows that this was installed. So there it is, Hydra node implementation of this. So it means this first part was done correctly. Then here, the next step is to create variables on your machine, on your system. Right. Environment variables on Windows and here is different, but here we are creating a variable path. And then here again, we've got this Genesis, and we've got this one for the ancillary verification key, aggregator endpoint. So basically what is happening, this variable here, it is pointing right this here. So this is a way of Linux to create system variables. Let me check one. How you create it. You create it by clicking the word export. Then this is just a name. Normally variables in Linux, they are in capital letters, uppercase. So let me show you the ones that those variables are already set. This automates, this is a scripting, it automates use of, instead of every time you'll have to say kill this, you only call this once, then it works. So let's check what is in the variable by using a command called echo. And then you always put a dollar before the name of the variable. That one is empty. So let me set it so that you see. All right, they are set. Now let's test echo this one. Do you see now? I'll show you. This exported created these variables and then it set the data to these variables. Like here, I'm checking what is inside this Genesis. Use echo the dollar there. The dollar and the name of the variable, there is no space. So this is the content of the variable. So now I can use dollar this in my scripting going forward. It will be fast. Right, let's go to the next one. The next one here, it says we need to download a Cardano node. A Cardano node is an application with the ledger, which has the blockchain. Each computer that the stake pools use has got a Cardano node, that application that, what we call it, distribute all our funds to all other computers so that there is no one central point of failure. So here we have got a tool called Metril Client. This one will download and install a small Cardano node on your machine. I did install it. It took less than 15 minutes on my machine. I don't know on your machines how it is. It reached 100%, finished, then tried to run. Then there was an error somewhere, which means maybe this thing has been upgraded. So maybe the upgraded version is no longer, it needs something to be reset. But all what I'm telling you, this step is for installing this Cardano node. Take it that that Cardano node is running. The next thing is installed. Next thing is you need to run that Cardano node with the following configuration files. So this Cardano dash node is a command which you get after installing a Cardano node. Just like when you install a CLI, get certain commands. So this one, the run, Cardano node run, requires 4 parameters. First parameter is the config, dash config. Next parameter is the dash topology. Next parameter is the dash socket path. Then the last one is the dash database path. And each of these options, like the config, here we are giving it a file config.json. This one we are giving it a file topology. This one we are giving it this path. And then this one the TP. So that command, we run it, it will start the Cardano node. So it will start downloading the blocks. Right. Then it did, I'll just show you and stop it again. Right, this is what it does now. It is downloading and syncing the blocks from that installed Mithril Cardano node. So it is downloading the blocks onto the database, local database. Right, this one is a bit fast. It will finish quickly, but there is somewhere where it crashes. So I'm going to stop it. But at least I'm giving you the visual so that you see what do we mean when we say run a Cardano node. And when it runs, what does it do? It pulls up blocks of transactions onto the local database. That is why you need that TP. Right, let's go to the next. Let's say the Cardano node is at 100%, which means it is fully synced. And the next thing is you can run this Cardano-CLI query tip to get the latest information. Let's call it in a simple way, the latest information. Then you can see that it is updated. It will show you something like this. And then first, this is a key value object block to show you the block, the epoch, error, the hash, the slot, and then the slot in epoch, slots to epoch end, and then sync progress 100%. This information from query tip shows you that you are ready to go to the next step. Your node is fully synced. Now, here comes the everything is okay. Now it means we can start now with the application. I will explain it in easy way, but I think our time is a little bit. Don't know if you are not in a hurry, we can. Let's finish this because we are recording. I will also try to be fast. Right here, I've got two people, Alice and Bob. They are going to send each other money using a Hydra head protocol. Using Hydra. You will see how it differs from the normal way we use our wallets. So here, what Alice will do, this script, this what you see here, this is going to create a credential directory called credentials for Alice, also for Bob. So this is for Alice, this is for Bob. So I run this for Alice. You run this on your machine as Bob. Daniela, you run yours as Daniela. So we will be three here. Where does it, each of us generates a verification key and a signing key. So let's say Xavier, on your own, you also run this on your terminal. Then from your side, when you use Cardano CLI address key gen, which basically means Cardano CLI create a wallet address key called verification key .vk and SK for signing key. So you can see this is explained here if you are seeing this for the first time. Verification, this is signing, key find. So basically those keys are stored on a folder called credentials. That is why you started by creating that folder. And you started by this. You can try it, but I don't think it's going to run. It might run. Let's just try it there. There we go. Let's check if that folder is there. You can say cd. Then we go to credentials. Yes, it is there. Let's check here. There, you see those keys. They have been generated inside. We can check these keys. Let's check for Bob SK signing key. There, this is how it looks like, the key. The type of the key, this is the payment signing key Shelley error underscore. It is using the cryptographic called ED25519. This is the ones we are using to generate the mnemonic words for our wallets, signing keys, verification key. So description, this is a payment signing key. This is the hexa, the binary part of the data. I think this helps you also learn some things that you don't know. You can do the same with the Bob-node. So here, this node here, the address will build on produce an out file here, which is called Bob node address. So this one now is going to produce an address, a wallet address. I think explaining this thing is not so important because we have seen all this. All right, so from this step here, on this step here, we have got now the key pairs for both of these. Each one of them has got a pair, a signing key and a verification key. We normally do this for our layer one. Next, you need to find these wallet addresses. You see this address for Bob and also for Alice. We found them using the faucet. You can go to the faucet and find them. You're familiar with that. Right. Now let's go to the next most important. Then here we can check the balance. The most interesting thing here, when you are checking the balance, and this, you are checking the balance on your local node. Right, let's go to the next. Generate Hydra pair keys. This is now we get onto using this Hydra protocol. So we generate key pairs now for this layer 2. So which means each one is going to have now 4 pairs of keys. So now for Alice, we are going to run this. I don't think for me, if I run this, it will work because I didn't really finish running everything. But just to run it, you can see here it says Hydra node command not found because Hydra node didn't fully install on my machine here. So, but what this will do, the Hydra-node is a command line tool. So the gen-hydra-key is the command line Hydra, the command for generating a Hydra key. But this type of key is called this one, Alex-Hydra. This is one key. Then here also for Bob. That one is for Alice. If you are collaborating with another individual, exchange the verification keys. So Alice, Bob, this node verification key. And then the verification, these are the payment keys. So like for example, I can give you my key, Xavier, and then Daniela can give me her keys. Why? Because I put funds onto them. You put funds onto my wallet address. The keys they are talking about here, these are payment addresses we are using all the time. So then we launched the Hydra node, same way we launched the Cardano node. So the Hydra node will be running on my machine. Daniela, Xavier on your different machines. They are running. And then they will connect to each other. What will make my node of Hydra connect to yours? Because of the protocol parameters. It will direct it to look and connect to the local network that we have created with this Hydra head protocol. So it will form a more like an intranet, 3 or 5 nodes connected together to form a network so that it only works locally. Then it is going to, like on HTTP, this is the local host. But if I'm testing it on the same machine, but if we are 3, then this will be your IP address and your port. This will be my IP address, my port. Then number 3, Xavier, your IP address and your port. Right. Cardano CLI query protocol dash parameters. Query is more like extract information. And then after extracting that information, save it on this file. So this command adjusts the fees pricing mechanism to 0, ensuring that transaction within the Hydra head incurs no cost. So in summary, the Hydra head participants, which is Bernard, which is Xavier, which is Daniela, representing Bob and Alice, exchanged and agreed on. So the Hydra head participants exchanged and agreed on the following. We exchange and agree the following things so that our nodes connect together. Otherwise, our nodes, how will they know each other? Xavier, you give me your IP address so that I enter it onto my node. If you have created a peer-to-peer application like a chat, those chat, we do the same things. For my node to connect to yours, I need your IP address and the port. And then from there, the moment I put it onto my node will find your machine, and then it will then connect to it via that port. So there we have it. And then the second thing we share is the Hydra verification key. These are the payment keys where we are going to be sending each other some test header. Then Cardano verification key to identify them on the blockchain of the Cardano. And then lastly, the protocol parameters to use in the Hydra head. So these protocol parameters will direct and make the nodes connect to each other, know each other. Like for example, if you, 2 of you and me, we met up in a very busy street, we have a way of identifying each other amongst the crowd. As an alien being looking at us won't know, but I know that is Daniela. You will say that is Bernard, that is a Xavier. Then in that whole crowd, we will come together and greet each other. Why? There are certain protocol features that we share each other, we know that identifies us. Language, names, the way you dress, whatever. It's the same. The nodes need these protocol parameters to be able to find each other on the internet. All right, let's get to number 3. The time I see 6 minutes up. Start the Hydra node. So Alice, which is, let's say, Daniela, Bob, Bernard, then we've got Xavier that side. All those participants, we start on our machines, the node. So what do? We run this. I run this. you'll see here is Alice. I want you to see one thing. When I run this, I'll give this the verification key of Alice. When it's Alice, Alice is going to give this the verification key of Bob, so that this can pay Bob, so that this can pay Alice. And I want you to see another thing here. One machine is for Bob. This is for Bob. It is listening at port 5002. Here, because it's on the same machine, this is for Alice, which is listening at port 5001. But in the event, this will be two different IP addresses. We are going to do this practically. We are going to see it working. Then verify that the node is operational by establishing a WebSocket connection to the API port. So we use this command, WebSocket ws.127, then to the port. If it's Alice, we see the port is 401, Bob 402. This opens a duplex connection. So Bob and Alice will connect. You should see messages from your own different machines. It will say my PA Bob node 0, PA connected. And then on the other side, maybe it will say Alice, it will say Bernard, it will say Xavier, Daniela, whoever is connecting with some information that we have here. A timestamp, then the head status idle at the moment. And then Hydra node version, of course, give you that version. Then me, this is the verification key, this is payment key in a hexadecimal format, not in a batch 32 format. Sequence 1, tag, greeting, this is the message. And then the other one also will see greetings. All right. Step 4, open a Hydra head. We use this tag on the WebSocket API. Just put this, say init. And then the next thing here, the initiation process might take some time, as it includes submitting a transaction on chain. Upon successful initiation, both Hydra nodes and their clients will display head is initializing message, listing the parties required to commit. To commit funds to the head, choose the UTXO you would like to make available on your layer 2. Use the HTTP API of Hydra node, Hydra-node to commit all funds given to either Alice or Bob verification keys beforehand. Right, I think this one I've explained is very similar. The only thing here now, we are building a transaction. We are taking a UTXO, which means on a wallet address, we have got that thing called UTXO. Let's show it quickly. And then that UTXO, let me just open one here. It is where you have got test data and assets like tokens and NFTs. This is the thing we are talking about. This is what we are going to spend with this feature here that you see. Where's this? Yeah, this one here. When you query this UTXO, what is that UTXO thing? Please show your students this thing here. So let them see the actual UTXO on a blockchain explorer. It has got a hash, it has got an index, it has got these, let's call it assets. We've got a test data, then we've got a, if you check this one, assets, NFTs, whatever. Then we've got the side here, this is the datum, extra information that is within this. All this that you see here, it is one UTXO. Right, also Bob has got the same commands, you run the same on your own node. Alice on your own node, Bernard on your own node, Xavier on your own node. And then we move to step 5. So you have got this documentation read into detail step by step. So let me finish quickly. Our time is up a little bit. So step 5, use the Hydra head. You follow these steps. Then here you make some payments of 1 ADA. This command line will pay and produce. This one actually what it does, it builds up a raw transaction. And then you take this raw transaction that is built up here with this. This one is going to pay Alice. And then here you sign. See, this is where you use your signing key. Remember that Alice signing key here. She will sign. Then the funds will move from Alice to Bob. Right. Then you submit the transaction. Then here, congratulations. You just processed your first transaction on a Hydra head off chain from the Cardano. Then you can close. Then what happens when we close? Then there is going to be a reconciliation of the layer 1 on what happened on layer 2. Because remember, we need the layer 1 blockchain state to be correct. We don't want when people they are on layer 2, they steal funds, they rob each other, and then they submit incorrect transaction and state of their wallets onto layer 1. Then it messes up everything. So layer 1 is going to use the validation done by layer 2 and also maintain an up-to-date state. If Bob paid Alice on layer 2, Bernard paid Xavier on layer 2, Xavier paid Daniela on layer 2. But remember, on layer 1, when we are on offline, layer 1 doesn't know who has paid who. It is only when we close our Hydra head, we close, and then it does what? It syncs, and then it corrects everything in a way that is trustless. I might have made some mistake in some of the explanation. Read through and practice it, and then teach it to your students, because one of our responsibilities is to make sure that every one of our students has got understanding of Cardano Technologies layer 2 solutions, for example, like I have explained today. Right, thank you. Oh, Prefina joined. I was on the other side. Welcome, Prefina. I don't know when and where you joined.
Thank you, sir.
All right.
Thank you so much, sir.
All right. Thank you so much.
sir.
It is exciting. It's very interesting, at least to have our hands
Thank you, sir.
and apply ourselves to one of the greatest technologies of blockchain time. So the links, Prefina, how do you get to this document? So I'll show you so that you don't get lost, because Prefina, you have got, I don't know how many
Okay.
students. You will need to, at some time, let them know, apply themselves into this technology. Right, so how do you get here? Just go to our normal Coxygen.co universities. And from here, you go to the GitHub. Under GitHub here, you type Hydra. There it comes out. Cardano layer 2 solution. When you click on it, I have put a summary of it here, which might differ a lot with the original documentation. Right, so
Okay, sir.
the moment this opens for you, click this Hydra documentation. Okay? Click this, then you can go through, like, let me click so that you see, it takes me straight to here, to this part here. Okay, let me stop recording. Thank you so much.